So today we're learning about general form. Girls, Angelica, open up your book, go to the right page. So today we're learning about general form. The most important point about general form, my pen isn't writing. A, B, and C don't represent anything. I want you to write that in on the first page. My pen would work. They don't represent anything. They're just numbers. Letters. But like you would replace the letters with a number. So they're like coefficients. So they don't represent exactly. Like before our coefficients on the x, like in our first form, the m would become a number. So like 3x, that 3 was our slope. The A, B, and C don't represent anything. They have no context, no meaning. Just when it's in general form. So only when it's in this form is that the case. And that's what I mean. Like this form is not super helpful. It's easier to work with in future mathematics courses, but at this point it's super useless. And then just to like put like a cherry on top, there's even more restrictions with it. Sorry, Gavin. Okay, so as I was saying, general form isn't super helpful, and then they add some extra complexities to it. So the extra rules, first off, A, B, and C, you cannot have decimals or fractions. So that means it's an integer. So we can't have any fractions there, so we're going to have to get rid of the fractions, as well as A has to be positive. So I'm just going to add a handwritten note in here, as should all of you. A, B, and C cannot be a decimal or a fraction. So we just have to change the form by multiplying it up. And we'll go through examples of this to make it no longer a fraction or a decimal. It's annoying. And truthfully, the reasoning for this is just to make it like more convenient when you move on with higher mathematics. For our purposes, it doesn't really have a point, but it's just kind of the rules that we have to follow because we're setting you up for future math. So this first point here, convert to general form. At the end of the day, when we're converting to general form, we're just making it equal to 0. It doesn't matter which side of the equation 0 is on. So it could be on your far left side, it could be on your far right side. Do whichever option's easiest. So in this case, if I subtract y from both sides, I get 0 is equal to 5x minus y minus 8. So our general form, I just want to like show you guys this, is ax plus by plus c. So in this case, that means a is equal to 5. B, we would say, is equal to -1, right? If there's not a number written there, there's that hidden 1. And then C would be equal to -8. So like I'm just comparing so you guys can see how they like are represented here. That's all. In B, same idea. To go to general form, I'm going to subtract y from both sides. I could subtract the 2x, the x and the 7, but that's just way more work, right? Do it the easiest way possible. You're less likely to make mistakes then. So if I subtract y from both sides, I get 0 is equal to 2 over 3x minus y plus 7. But we're not allowed a fraction. So how do I get rid of that dividing by 3 there? Good, right on. So we have to multiply by 3. You have to multiply every single thing by 3 then. So technically speaking, we're also multiplying 0 by 3, but that's equal to 0. I want you really to remember though, it's everything by 3. It's like the entire side by 3, which means each term is being multiplied by 3. So when you actually multiply that out, 3 times 0 is 0. 2/3 times 3 leaves us just with 2. -1 times 3 gives us a -3y plus 21. Annoying that we have to do that. The next question is a little bit trickier because I now have two fractions. So let's add in a note here. So when two fractions are in the equation, you're going to multiply by the lowest common multiple. So what's the lowest common multiple between 4 and 5? 20, good. So first let's subtract y just because to be consistent, that's what we've been doing. So I get 0 equals negative 1 over 4x minus y plus 3/5. So really important, x also has to be positive. So we have an annoying fraction, but we also have an annoying negative. So in this case, we're actually going to multiply by negative 20. Because a negative times a negative cancels out our negative x. So then our x term will become positive. Everything else switches, but we don't really care about everything else. So times negative 20. You can write it, so the first time I wrote it is like multiplying everything by 3. You could also write like times negative 20 with each term. Whichever, you don't have to write it at all, but whichever method you prefer if you want to write it. So 0 times negative 20 still gives us 0. When you're multiplying fractions by a whole number, there's a couple different approaches you can use to make life quicker. So I'm going to write them out just so you guys can visualize it a little bit more. You don't have to write this down, but this is like the processes you can do in your head. So you could think of as negative 1 over 4 times negative 20 over 1. So I would get positive 20 over 4, which is just 5. That's doing like the whole math, right? Like that's just, you're multiplying fractions, that's your whole process. Or your other option, and this is what I do in my head because I can do this way easier. I do my division first. So I do negative 20 divided by 4. What does that give me? Negative 5, and then I times that by the 1. So I like break it into just steps like that because I can picture that a lot quicker in my head, and it makes it a lot easier. Sorry, negative 1 times negative 5 still gives us that positive 5. You do not have to write these down. You totally can just do that in your head if you can, but I just wanted to go over like the process that you're doing in your head. If you need to write it down, write it down. But we're going to be doing lots of these, and unfortunately, there's not usually a ton of room for those steps. Remember, at the end of the day, this unit test, you don't get a calculator. These are the types of numbers we're going to have. They're not going to be super hard numbers. So my first term ends up being 5x. For my second one, negative times a negative gives me a positive 20y. My last term, so like I said, how I do it is I go 20 divided by 5 gives me 4. 4 times 3 gives us 12. In this case, it's going to be a negative 12 though. Break it down however it works best in your mind, right? We all think a little bit differently. As long as you're getting the right answer, that's what counts in the end. A second to catch up. Okay, on the next questions, we're given general, and we want to put it into, we want to find our slope and our intercept. So whenever it says that, that means we're just putting it into slope point form. Sorry, slope intercept form, my apologies. Which means we're going to solve for y. You can solve for y on either side. Doesn't matter where y is. So in this one, my y is currently negative. So if I add 5 y's to both sides of my equation, it's a little bit easier just by manipulating. So then I'm going to get 2x plus 25 is equal to 5y. On your guys' quiz and just like throughout the year, I've noticed this is an area where we struggle a little bit. How do I cancel out that 5? Go ahead, Matt. Divide by 5. What's really important, you are dividing the entire side by 5. Everything on the left side of that equation is divided by 5. So you can think of that as like 2x divided by 5 as well as 25 divided by 5. Like you could write it out that way as well, just fine. Whichever your personal preference would be. Either way at the end, I'm going to get 2/5 x being my slope. 25 divided by 5 is 5. So this question wasn't actually asking just for the form, actually to identify. So my slope is 2/5. My y-intercept is 5. That's actually your answer here. Notice, neither of those values happen to be the A, B, or C. A, B, and C, so the numbers in this case are useless, have no meaning. Okay, for the second example, if you wanted to, my y is already positive, a little bit easier. So just to show you a different way, if I subtract 6x from both sides, I'm also going to add 15. Like we're getting to the point where algebra shouldn't be super hard anymore. So you can do 2 steps at once. So I'm going to subtract 6x and add 15 all in like one line. So my x's are going to cancel and my 1's are going to cancel, leaving me with 2y on my left side, negative 6x plus 15 on then my right side. From here, I divide by 2. So again, you can use whichever approach you want. If you want to write out divide by 2 multiple times, that way you don't forget that, do it. But every single thing has to be divided by 2. So then I get negative 3x plus 15/2. Because 15/2 like ends to be 7.5, you're welcome to write 7.5. That's fine for me. But if it doesn't end nicely, like if it's not a nice decimal, leave it as a fraction. It's a good habit to leave it as a fraction, but for our purposes, I can see why you might want to convert it. What is the slope for this line? Just -3, no x. What is your y-intercept? 15/2. Okay, so this next question is like a really good level 5-6. We have 2 lines and they have the same y-intercept. Determine the value of k in our second equation. So really good, like just have it to be in. When in doubt, solve for y. So if you read a question and you're like, what? Solve for y. So in the first one, we have 3x minus 4y plus 8 equals 0. So I'm going to, in this case, add 4 y's to both sides because I think that's the easier approach. So my left side is 3x plus 8 equals 4y. Now I'm going to divide everything by 4 to cancel that out. So then I get 3/4 x, 8 divided by 4 is 2. So we know the y-intercept of both of these is going to be at 2. Go ahead, Hafsa. It's not. K does not equal 2. We're only like partway done. So let me finish. So now this equation, there's a couple different approaches to solve from here. This equation, remember, K has no like actual meaning. We just know that there's a number there. What do we know about our y-intercept though? It's at +2, but we also know we have a point then at 2 and 0. Sorry, I said that backwards. At 0 and 2, right? So we have a data point. Or I have a value for x and y now. So you can plug that into that second equation, and then we're left with only one variable. So I'm going to take this equation, 5x minus ky minus 6 is equal to 0. And I'm going to use those coordinates. So 5, instead of writing x, I'm going to write 0. Instead of writing y, I'm going to write 2. Because I know that data point is on this equation, right? Because we know they have the same y-intercept. So they have one point that can satisfy both equations. And so if I plug it in, I can now isolate and solve for that k because it has to work out. So 5 times 0 is 0. If you want to write 0, great. If you don't want to write 0, just fine. K times 2, we always put our number first. So I'm just going to rewrite it. Do you have to? No, but it's more familiar and makes me more comfortable. So now I'm going to add 6 to both sides. So then I get negative 2k is equal to 6. Divide both sides by that negative 2. So then I find out k is equal to negative 3. You could solve this question using this method, which I personally think is easier, or you could have isolated, like gone through the second equation and solved for y, and then compare to figure out what 2 is. But I think that method's a little bit trickier. Yes.
Right, and then to, like, I don't get how it's like that. I don't know. Like, why is it worded like that?
Like, why is the question worded
Yeah,
like that, or?
how do you interpret that?
What aspect of it don't you understand? Can you be more specific?
Okay, so because there's like 3 numbers in each equation,
Yes.
and then I get that you like subdivide another number into like k to make your coefficient, and that's what you're trying to figure out.
Yes.
But then, oh, okay, so the y-intercept part is just there because it's just there.
Well, it's there because that's how the two equations are related to each other. Without having a common piece of information to plug in, we could never solve for k.
So to like check to see about it, like you would y-intercept.
Yeah. Yeah. Totally. Okay, turn the page. Okay. Which of the following lines are perpendicular to this first line? This question is just getting super repetitive. I want you guys, we're going to change it and cross off these because you would do the same thing over and over and over again. And I just feel like that's not worth our time. I want you to find the slope of this line. How do you do that? Good. So in general terms, that's a specific step, Mateo, but you're totally right. Solve for y. I want you to go through that. Solve for y in this equation. So we add 2y to both sides. Again, you could do slight different variations of this process. As long as you're doing the correct algebra, you should be fine. What is the slope of this line? Okay, Carissa? 2. So what would a perpendicular slope be? From another than Carissa. Perpendicular slope would be what then? Good, right on. So perpendicular slope, you change your sign. So in this case, it becomes negative, and I reciprocate that fraction. Raise your hand if you got a slope of 2. Which one did you do? Did you do like I? Oh, I did make my circle very big. Okay, and Brady, let's check though. That's okay. Brady, what did you get for a slope? You should have gotten negative 1/2. if you just change the numbers. Okay, let's look at the next example. Write the equation of a line perpendicular to this first one and that has the same y-intercept as my second line. So this is a big question. So at the end of the day, we are given two lines. We're taking a piece of information from each to make a third line. So let's look at this first one. So this first one, we're getting our slope from it. So the equation is 2x plus 5y minus 7 equals 0. So I just want to show you, I'm trying to just give you varying different ways to do this. So I subtract 2x from both sides, and I'm going to add 7 to both sides. Remember, it's both sides of like that equal sign. So then I get 5y equal to negative 2x plus 7. Divide every single thing by 5. So you don't have to do this, but some of you might really benefit from doing this. If you draw like a little sketch over to the side to help you visualize the question, it might be really helpful. So this first line is at negative 2/5, so it's a very gradual slope crossing at 7/5, so just slightly up. So my first line is something like this. What is a perpendicular slope to this first one? Good. Change my sign so we make it positive and we reciprocate it. So the slope of the line that we're developing is going to be 5/2. Second equation, we're getting our y-intercept here. So we have 2x plus y minus 6 equals 0. So I'm going to isolate for y, cancel out those x's by subtracting 2 x's from both sides and then adding 6 to both sides. So then it's in the form mx plus b. What is the y-intercept of this line? Plus 6. Good. So the equation, the graph of that line is at plus 6, so it crosses up here. Oops. It has a negative slope, and it's going to be a little bit steeper than my previous one. So maybe it's a graph that looks like this. Very much generalizations I'm making here. Like when I sketch it, it just gives me an idea for a little bit context. So now we want to take those two pieces of information to make a third line. Perpendicular to my first, so it's going to be a 90-degree angle crossing through that y-intercept. So the red line is like, we need to make an equation for that. Whenever you're making an equation, you have to use one of these two original forms, so slope-intercept or slope-point. Easiest most of the time to go with slope-intercept form. So we're going to use y equals mx plus b. I am simply going to replace the m with my slope of 5/2. My intercept of 6. This question was like extra annoying. Oh, sorry, Tim. Yeah, and I'm recording right now for you. So rest of this question's a little bit annoying because now we have to make it into general form. So they actually wanted our equation in two different forms. So I'm going to subtract y from both sides. So now I get that beautiful 0. Then I get 5/2x minus y plus 6. Am I done? No, I can't have that fraction. So everything has to be times by 2. So then I get 0 equals 5x minus 2y plus 12. That's a big question. Again, that's a really good level 5-6 question. Taking lots of different pieces of information, pulling lots of pieces together, and understanding what's going on. Like there's like interpretation parts to that as well.
Is this a level 5-6?
Yeah. well, in the moment right now, it's currently unfamiliar somewhat, but no longer unfamiliar. Yeah, that's fair. Crazy graph. Only the first term, only A has to be positive. So only the coefficient with X always has to be positive. The very first one has to be positive and no fractions. And like, I cannot stress this enough. The reason why there isn't really one. Just people decided, mathematicians back in the day were like, we're going to make restrictions on here and annoy everyone. Okay, this last question, questions like this are really good and come up often on the diploma exam. I know that's 2 years away, but we try and like sprinkle them in throughout our math courses to help you prepare for them. So a student made the following statements about a line with this equation. It is a slope of 5. It's parallel to this other line. The line passes through, -2 and 1. So we're going to go through this carefully. First step, solve for y. So if we have 2y equals 5x plus 12, solve for y, I'm just going to divide everything by 2. What is the slope of this line? So is statement 1 true? No. So right away, this actually tells us our answer, because that means 1 can't be in any of these. So it tells us our answer is C. So like, I don't think this is a very good question, because personally, I want you to do more than that on this question. Statement 2, the line's parallel to this other equation. Again, you're just solving for y, so I think we can do that. We've done that enough now. I just want to review what would you do for statement 3 to check if that's true or not?
So, you could plot it on the graph. You know what the slope is.
Totally, but you don't have graph paper, you only have the ability to sketch it, and you don't have your calculator. So unless you're really good at drawing, that becomes way harder. Plug it in. Plug those points in. Often you guys forget that this is an option. So let's go through what that means to do that. So Chris, your idea would totally work. You just don't have the resources. So my equation, 2y equals 5x plus 12. If it passes through that point at -2 and 1, the equation will work out. So I'm going to replace y with 1. I'm going to replace x with -2. 2 times 1 is 2, so I get -10 plus 12, which means 2 equals 2. At the very end, that's a true statement that 2 literally equals 2. If that coordinate didn't work in the equation, so if at the end, let's say we got 2 equals 3, that means that point doesn't pass through the line. Matt, can you wait like 4 minutes? Yeah. Does that make sense? You always can plug a point in to check. It's an option that we often forget about. Okay, we have 5 minutes left. I want to do a quick review. If you guys turn to page 578, it's a blank page that we can take some generalizations in to review some concepts. 578. I'll go back there. Okay, turn to page 578. We're just going to do some generalizations. What is slope formula? Just slope. What is just slope? No. Good. Y minus y over x minus x. Rise over run. You guys should all be writing this down. This is really good, quick review of this unit so far. Just on the blank page, because there's space. Page 578. Okay, we're going to draw out 4 Cartesian planes. 4. Half, so we're writing this down. Okay, positive slope. We're going up our chairlift. We're about to start skiing. We're really excited. Positive slope. Negative slope is opposite. What's a 0 slope? Go ahead, Matt. Good. Horizontal line. All of these are straight. We're only looking at linear graphs, so they're all straight. But specifically horizontal. Undefined is a vertical line. Okay, if you drew, these are quick sketches, so I'm going to approximate my equations here. Make sure your equation is like matches what you drew. So this first equation for me would have been like y equals x. It's going through my origin. So if I wanted to think of it, I could say 1x plus 0. My second equation would be like maybe at negative 1/2 x minus 1. Yeah, totally. Third equation, to describe a horizontal line, it's always just going to be like y equals 5, or however high up or how far down your equation is. A vertical line you describe using x equals. So for me, mine's fairly far right, so I'm going to say x equals 10. These last 2 are the most common that you are likely to forget. Okay, slope, intercept form. So hopefully we all are remembering y equals mx plus b. So the components of this, depending on like the wording of the question, information given, but how to be able to use it, you either need a graph and like you'll count it out and actually like read the graph to come up with your equation. Or you need 2 of the following. So you either need slope, the y-intercept, or a different point. And then you could put it into that form. We will go into more of this stuff next week, but I just think it's really good for us to have it written out all in one kind of spot. Slope, point form is our y minus y1 equals m x minus x1. So to use this form, again, you could do this all from a graph, or you need 2 of the following again. Slope, or 2 points. Our very last thing, which I hope we're remembering, parallel lines. What do we know about them? Good. Same slope. Your shorthand is an M with two straight lines beside it, or like LL kind of thing. Perpendicular lines. Good job. Which we abbreviate with that symbol. Our last one, let's just write it down. General 0 equals AX plus BY plus C. A, B, C have no meaning. No fractions allowed. This is my last sentence, I swear. A is positive. So this is all of the new information that I've basically showed you so far in this unit. Yes, there's more to it. Okay, zoom in. I'll zoom in. Sorry. So that's all of our new information. You still have to know like intercepts, what they mean, and different terminology, but that's a really good summary point. You have 3 minutes. I will give you 3 minutes. If you write down the questions from lesson 3, so like these, we gotta flip back like 2 pages, then as soon as they're written down, you guys can go early. Oh, 1, A and B. I didn't actually say. 2, 573. 573, page 573. Following. Okay, so are you guys done with the notes? Can I zoom in? Here, let me do it like this. I'm making it easier for you guys. Just chill. For 3B, you only have to do the X and Y intercepts. I'm making that question smaller. Yeah, so grade 10s. These questions are not due, so you don't have homework, but we will have class. Have